1.3.6. Solve the following system of equations using substitution or elimination. So let's review quickly 126 before we get into 136. So pause the video, give these a try on your own. Make sure you remember how to do those. Check your 126 notes if you don't remember. Okay, we're back. Here, I notice we have opposite coefficients, so we can add the second equation to the first using elimination. So 5x plus negative 2x is 3x. Y plus negative y cancels out, and 9 plus negative 7 is 2. We divide both sides by 3, and we get x equals 2/3. Next, we plug in 2/3 for x into either equation, so I'll pick the first. So 5 times 2/3 plus y equals 9. So that's 10 over 3. Subtract 10 over 3 from both sides. We get y equals 9 minus 10 over 3. Well, let's write these as one fraction. So if we want to write this over 3, we got to multiply the top and bottom by 3. So we get 27 over 3 minus 10 over 3, which common denominator, subtract fractions, so we get 17 over 3 for y. So our solution would be 2/3, 17/3. To which you could check, make sure that that'll work out. Next one, we do not have the same values here, so a couple ways we can go about this. We could use substitution or elimination. I'll use substitution just to get practice with that. So if we take this first equation, let's subtract 3y from both sides. Then multiply everything by -1, so we get x equals 3y minus 12. Now we can substitute 3y minus 12 because it's equivalent to x in for x here. So we'll have 6 times 3y minus 12. 6 times 3y is 18y. 6 times -12 is -72. 18y minus y is 17y. Add 72 to both sides. That is 51. Divide both sides by 17 and we get y equals 3. So we have y equals 3. Now let's plug y back in here. You could do either equation, but I'll do it here since it's already x equals. So we get x equals 3 times 3 minus 12, or 9 minus 12, which is -3. So x is -3, y is 3, so we get the point 3, -3. Okay. All right, so there's our review with elimination, substitution. For 136, okay. So what we'll be doing is we'll be building upon that. We'll be having to solve using elimination or substitution, but in this case, we're gonna have to create some equations as well. So for number 1, it says, Jalen wants to go shopping for decorations for the school dance. He goes and buys 7 balloon packs and 8 tablecloths for $43. He goes back the next day to buy some more for extra and buys 2 balloon packs and 4 tablecloths for $14. How much were the balloons and tablecloths each? So our goal is to figure out how much are the balloons, how much are the tablecloths. So let's just pick B as a variable to represent balloons, T as a variable to represent tablecloths. You can choose X and Y if you want, whatever you want to do. So I notice 7 balloon packs and 8 tablecloths cost $43. So 7B, because B represents balloons, plus or and 8T costs $43. In addition, we're told that 2 balloon packs, or 2B, and 4 tablecloths, 4T, cost $14. So you can see we have 2 equations, 2 variables in each equation. So we can use substitution or elimination now to solve for T or B. Remember, to use substitution, you need to get a variable by itself. To use elimination, you need to have top and bottom either same coefficient for a variable or opposite, so positive and negative. As I'm looking here, I'm noticing if we multiply this second equation by 2, then we can get 8t, so these will match up. So let's do that. So 2 times 2b is 4b, 2 times 4t is 8t, 2 times 14 is 28. So we're going to look at this equation. We've modified it. along with our second. So let me just rewrite over here what we've got. So we have that first equation. We've modified our second. Still the same equation, just multiplied everything. Now we have common coefficients. So if they're the same sign, we subtract so that our t's will cancel. So 7b minus 4b is 3b. 18 minus 8t will cancel. 43 minus 28 is 15. Now we can solve for b. Divide both sides by 3, and we get b equals 5. So we determined b represents balloons, so we've determined balloons cost $5. Now we just need to figure out our t. So we plug 5 back in for b into any of these equations. So I'll just pick this one here since it's close. So replace b with 5. So we get 4 times 5 plus 8t equals 28. 4 times 5 is 20. Subtract 20 from both sides. We get 8t equals 8. Divide both sides by 8. And we get t equals 1. So tablecloths cost $1. And you can plug those back into the original equations and make sure everything checks out. But you'll notice here what we're doing is we had to come up with the equations, pull them from the word problem, and then use substitution or elimination. So the new step is coming up with the equations on our own. Okay. Let's do another together. Clarissa is selling jackets and book bags for the school store. One day, she sells 7 jackets and 6 book bags for a total of $160. The next day, she only sells 1 jacket and 2 book bags for $40. How much are the jackets and book bags? So jackets and book bags are what we're solving for. So I'm just going to use J and B to represent those. You can pick any letters you want. So let's find a couple equations. So she sells 7 jackets, 7J, and 6 book bags, 6B, for $160. Next, she sells 1 jacket, 1J, and 2 book bags, 2B, for $40. So we have 2 equations. So we can solve using elimination again, or we can use substitution. Again, it's up to you. What I'm noticing here, though, is that we have a singular J. So what we could do with this second equation is subtract 2b from both sides. So then we just get j equals negative 2b plus 40. And now we have an equation set up where j is by itself, so we can substitute that back into the first. So if we do that, we'll have 7 times negative 2b plus 40 plus 6b equals 160. Distribute the 7, so we get negative 14b plus 280 plus 6b equals 160. Negative 14b plus 6b is negative 8b. Subtract 180 from both sides. We get negative 8b equals negative 120. Divide both sides by negative 8. And we get b equals, what is that, 15? Yeah, 15. So book bags cost $15. Now we just need to figure out what j is, and we can plug that b right back in here to solve for j. So we'll get j equals negative 2 times 15 plus 40, so negative 30 plus 40, which gives us 10. So we determined our jackets are $10. And know with these problems, you can always check to make sure it works. We can plug 10 back in for j and 15 back in for b into the 2 original equations, and if they work, then we know we did everything correctly. Okay. All right. Why don't you read through this problem, try it on your own, and then we'll talk through it. Pause the video, give it a go. Okay, we're back. Lillian recently bought food for her family reunion. She bought a total of 23 hot dogs and hamburger packs. The hot dogs cost $3 each, and the hamburgers cost $5 each, and you spent a total of $95. How many hot dogs and hamburgers did you buy? So this time we're trying to figure out the number of hot dogs and the number of hamburgers. In the previous problems, we were trying to figure out their cost. So I'll use D to represent hot dogs and B to represent hamburgers, the number of each. So the number of hot dogs and hamburgers. So we're told hot dogs cost $3 each. So $3 per hot dog. Hamburgers cost $5 each for a total of $95. So if we take the number of hot dogs plus the number of hamburgers, multiplying by the cost, that should match up to 95. We're also told she bought a total of 23 hot dog and hamburger packs, so that's combined. So if D represents the number of hot dogs, B represents the number of hamburgers, if we add those together, we should get 23. It's a little tricky to come up with that equation. At this point, now we can solve using substitution or elimination. I'll go back to elimination here. So I'm noticing, let's match these up so they both have 3. So that means we need to multiply this whole equation by 3. So we'll get 3D plus 3B equals 3 times 23 would be 69. So now we have two equations. We've got 3D plus 5B equals 95, so that first one. And the second, 3D plus 3B equals 69. So now we either add or subtract these two equations. In this case, we subtract because we have the same coefficient, not opposite. So 3D minus 3D will cancel. 5B minus 3D is 2B. Make sure you're applying that minus in there. I see that mistake happen a lot, forgetting to do that. 95 minus 69 is 26. Yeah. From there, divide by 2, so we get B equals 13. So we've just determined B is 13. B represents number of hamburgers. So we bought 13 hamburgers. Well, let's plug B back into any of these equations. Let's pick this one since it's pretty easy. So we'll get D plus 13 equals 23. Subtract 13 from both sides, and we get D equals 10. So D represents number of hot dogs, to which we bought 10. Alrighty. Those are your notes for today. So really the key concept here is coming up with these equations. After we have those equations, we're just using substitution or elimination like you've seen before.